Okay, let's take a look at question number 15 on homework 5. This one is a word problem, but we've seen a few of these now, and this one kind of follows the formula that they've been giving us, so I wouldn't worry too much. It's a word problem, but it's nothing we can't handle. So it says the concentration of a certain drug in a patient's bloodstream T hours after injection is given by the following function. And so that C of T equals 0.2 T over T squared plus 7. So as we do with all of these, we figure out what these things mean in our function, because that's going to help us answer the questions later. So C of T, that's the concentration at time T. So if we wanted to know the concentration after 8 hours, we would plug in an 8. If we wanted to know the concentration after 5 minutes, we would have to plug in 5 over 60, which is 1/12. Okay, I just forced myself to do more math than I thought I was going to do at this time of night. So anyway, this just says that if you plug in a value for T into this function, you're going to get the concentration of the medicine in the patient's bloodstream. And so T here is time, T over here is also time. So, you know, if we had C of 8, we plug in 8 and we figure out what the concentration is after 8 hours. Okay, so what are they asking us for? They are asking us in A for the rate at which the concentration of the drug is changing with respect to time. I see a lot of words there, but the ones that I'm picking out of that are important is rate, R, rate of change. Okay? Rate of change, to us, we see that, and at this point we are pros, and we know that the rate of change is the same thing as the derivative. So that means they want us to find a function for the derivative of C of T. They want us to find C prime of T. Okay, we can do that. We've been finding derivatives this entire homework assignment, so there's no reason we can't keep doing it. In this case, we are going to have to use the product rule. I've been writing this down every time. Let's go ahead and do it again just to be sure, in case this is the first time you're looking at it. The product rule says you need the bottom function. I won't write the whole thing out here. The bottom function, so in this case T squared plus 7, times the derivative of the top. So take the derivative of this up here, minus the top times the derivative of the bottom, and we put that all over the bottom squared. So that's our quotient rule. That's what we need to be able to solve this. So let's go ahead and set it up. C prime of T, we want the bottom, so that's T squared plus 7 times the derivative of the top. Well, the derivative of 0.2t is just 0.2. Then we're going to subtract the top, so 0.2t, and multiply that times the derivative of the bottom. Power rule says that the derivative of t squared is 2t. We just brought down the exponent and subtracted 1 from the power when we were done. And the constant rule says the derivative of 7 is 0, so that's not of consequence anymore. And then we're just going to put all of that over the bottom, so this denominator here, the bottom squared. So that's going to be t squared plus 7 squared. And I suppose that if you wanted to simplify that, you probably should at this point, because we're going to be plugging some stuff in. I'm not going to go through all the steps. You can email me if you wind up having trouble with this, if you can't make it equal what I'm showing you here. But the actual answer is going to be 1.4 minus 0.2 t squared. And that's going to all be over that t squared plus 7 squared. So if you do all of the math here, that's what you're going to get. You're going to get 1.4 minus 0.2 t squared over t squared plus 7. So the next thing that you need to do, and you're going to need a calculator at this point, unless you are really excellent at working with decimals in your head, is for part B, they're asking us for how fast the concentration is changing half an hour, 2 hours, and 10 hours after the injection. So this means they're asking us at a specific time, what's the rate of change? Well, we need to use our C prime of t function that we just found. So that was C prime of t equals 1.4 minus 0.2t squared over t squared, let me make sure that looks like a parenthesis, plus 4, or not plus 4, plus 7, t squared plus 7 squared. That is sloppy as can be, but we're going to go with it for now. So what you need to do then is to plug in the right values for t. We want to know the time. So they're asking for, the first one is asking after half an hour. So t in half an hour is going to be 0.5. So you are going to have to find C prime of 0.5. That's just plugging in 0.5 everywhere there's a t. So 0.2 times 0.5 squared all over 0.5 squared plus 7 squared. So that's just plugging in a 0.5. I'm not going to do the math for you. You have a calculator. That should come out to 0.0257 for this one. Okay, that would be the answer. If you had the exact same numbers that I did, that would be the answer that you would expect there. We're rounding to 4 decimal places, so that's why that's the case. Just be careful when you're plugging this into your calculator that you keep parentheses around everything that's in the bottom. You might even want to, if you're entering it in, put an extra set of parentheses. Otherwise, it might just take the information on top, divide it by the information on bottom, and then square the whole thing, and we don't want that. You might even be better off doing this in bits and pieces and then plugging those bits and pieces into your calculator, just to be sure that there's no confusion. But you should have a number that looks something like that. Then it's asking you after 2 hours what it's going to be. So the second one is going to be C prime of 2. So that'll be 1.4 minus 0.2 times 2 squared. And that's all over 2 squared plus 7 squared. And like I said, you might want to enter the extra parentheses. Again, I'm not going to do the grunt work here. The answer for this one would be 0.005. And finally, the last one is after 10 hours. So I bet you could guess what we're going to do. C prime of 10. And that's 1.4 minus 0.2 times 10 squared all over 10 squared plus, 10 squared plus 7 squared, I think, yep. And that extra set of parentheses, that's a lot of parentheses. If you plug that into your calculator correctly, you will find that that's negative 0.0016. That's that 4 decimal representation. Now, if I saw this as an answer, I might think to myself, how can that be? How can they have negative amounts of medicine in their blood? That doesn't make sense. But what they're asking is not how much is actually in their bloodstream, but what rate it's changing at. So they're saying that after half an hour, it's still increasing in their bloodstream. It's still going up a little bit in their bloodstream. After 2 hours, it's still going up. The quantity's still going up a little bit. It's still being absorbed into their bloodstream, but just not quite as fast as it was here. And by 10 hours, it's starting to be filtered out of their bloodstream. So it's not that they have a negative amount. It's just that the rate at which it's in their bloodstream or entering their bloodstream has changed to the rate in which it's leaving their bloodstream. So don't be confused if you wind up with a negative answer for part of this. And I did skip a lot of the mathematics, the calculation here. I trust that you can do it, but if you have issues, I am more than happy to help you with it. Shoot me an email.